All right, before I start for today, I just want to remind you that you will need your beautiful illustration of our 8 tests for control charts out with you. So this lovely sheet, make sure you pull it before you start today's lecture. Okay, so here we go. Susan Tamara is Director of Personnel at the Antlers Lodge in Denali National Park, Alaska. Every summer, Mrs. Tamara hires many part-time employees from all over the United States. Most are college students seeking summer employment. The biggest activity for Mrs. Tamara's staff is the making up the rooms each day. The lodge has 385 rooms, and from long experience, Mrs. Tamara has determined that by 3:30 p.m. each day, the average number of rooms not made up is 19.3, with a standard deviation of 4.7. Although the lodge has a policy that guest rooms be made up by 3:30, Mrs. Tamara knows that there will always be a few rooms not made up by this time because there's a high personnel turnover and corresponding reassignment of staff to new jobs for which they are in a training period. Every 15 days, Mrs. Tamara has a general staff meeting. Before the meeting, she examines several control charts for the restaurant, the gift shop, and of course, housekeeping. For the past 15 days, the housekeeping unit has reported the following number of rooms not ready by 3:30. Make a control chart for these data. All right, so we're given a set of data, 15 days, and we're looking at the number of rooms that are not ready by 3:30. So before we make a control chart, we need to know a few things about the distribution of rooms not made up by 3:30. Mrs. Tamara is aware from long experience that the distribution is symmetrical and bell-shaped. It's approximately normal with a mean of 19.3 and a standard deviation of 4.7. So usually you see me summarize that somewhere. I'll do it right here. Normal distribution, 19.3 is the mean with a standard deviation of 4.7. Okay. A control chart is a plot of the observed values, vertical scale, in time sequence order. So the horizontal scale represents time. Place horizontal lines for zones A, B, and C, then plot the data from the table. Okay, so first we just have to figure out what are going to be those zones A, B, and C. Let me slide this up. So to find zone C, what I'm doing is I'm taking the mean, so the 19.3, and I'm going to add and subtract one standard deviation. So 1 times 4.7. So I'm looking at, well, what's 19.3 minus 4.7? That gives me 14.6. And then my other one will be 19.3 plus 4.7. That gets me 24. I'm just going to find them all first before I do anything else. Okay, zone B. Zone B would be the mean, the 19.3 plus or minus 2 standard deviations. So 2 times 4.7, just like so. So I'm looking at, well, what's 19.3 minus 9.4? That would get me 9.9. And then my other one would be 19.3 plus 9.4. So that gets me 28.7. All right, zone A. So here, 19.3 plus or minus 3 standard deviations. So 3 times 4.7. Oops, let me rewrite that nice and clean. 4.7. So that means 19.3 minus 14.1. So I get 5.2. And the other one, 19.3 plus 14.1 is 33.4. Okay, great. So I have all of my boundary lines. So right in the middle, my center line is always my mean. So right here where my mean is, I'm going to darken that and make that a nice solid segment like so. And I'm just reminding you that that is where the mean is right here. And then as I move away, I'm just moving in increments of standard deviations. So as I mark the above region, I'm just going up in increments of 4.7. So 19.3 plus 4.7 gets me 24. Add 4.7, I get 28.7. And then add 4.7, I get 33.4. Okay, if I start with the 19.3 and then I subtract increments of 4.7, I have 14.6 here, and then 9.9, and then 5.2. Okay, so then I usually draw in dotted pathways for all of these markers. Could be solid, it does not really matter. I'll draw them dotted. So right in here, I'm doing all the upper ones first. Okay, so we know that right here is the mean plus 1 standard deviation. Here's the mean plus 2 standard deviations. And here's the mean plus 3 standard deviations. I have to do the same with the bottom. So again, I'm just drawing in dotted pathways. If you drew it solid, that's really not a problem. Okay, and then right here would be the mean minus 1 standard deviation, the mean minus 2 standard deviations, and the mean minus 3 standard deviations. All right, so we're getting ourselves set up. I also just want to point out the A, B, and C regions. So the C region is the one that is closest to the mean. So here we have the C and the C. So from here to here, that is 1 standard deviation above and below the mean. And then as I move my way out, here's 2 standard deviations above and below the mean. And as I move myself out to here with the A region, from here to here, those markers, that's within 3 standard deviations of the mean. And we know that it is more common to have data that is closer to the mean within plus or minus 1 standard deviation. The further away that we get, the more unusual it becomes. All right, so now I'm plotting my data, and I have to do it in order. So down here, I also need to add in day number 1 through 15. So go ahead and add that in here too. Okay, and then here we have day number. Okay, so now we're ready to plot our data, and it has to be in sequential order. So I'm plotting my 1 at 11. And it doesn't have to be perfect, but it should be in the right region, so right about there. 2 and 20. 3 and 25. 4 and 23. 5 and 16, 6 and 19, just below the center line, 7 and 8, 8 and 25, 9 and 17, 10 and 20, 11, 23, 12, 29, 13, 18, 14, 14, and 15, 10, right there. Okay, and then with a straight edge or just with a free hand, you're going to connect the dots. And again, you're doing it in sequential order. Okay, and then I want to look at my control chart And I just want to look to see if I see any sort of unusual pattern that is showing up. Do I see anything that looks like an out of control signal that would alert me that our systems are not running smoothly? In this context, we'd be checking to see if are we overstaffed, are we understaffed? Is there some issue that we're not identifying in our system? So here, if I look through it and I check my illustration of tests, if I look through 1 through 8, I'm really not seeing anything. So here I would say that this is a good example of a process that is in control. The process is in control, right? We're seeing that our values do appear to be pretty evenly dispersed about the mean. We don't see anything that is a change in the level of variation. So our standard deviation seems pretty stable as well. So again, it's in control. Our values are evenly distributed or dispersed about the mean. All right, so moving on. The main question is the following. As time goes on, is the variable continuing in the same distribution, or is the distribution of values changing? If the distribution is continuing more or less the same, we say that it's in statistical control. A control chart is really meant to be a warning device. It's possible to get a false alarm. In practice, whenever a control chart indicates that a process is out of control, it's a good precaution to examine what's going on. If the process is out of control, corrective steps can be taken before things get a lot worse. The rare fire alarm is a small price to pay if we can avert what might be real trouble. All right, flip it over to the next page. All right, so here we have the same setup, but different data. So over the next 15-day period, housekeeping reported that the number of rooms not made up by 3:30 to Ms. Tamara. We assume that we're still working with the symmetrical bell-shaped distribution with a mean of 19.3 and a standard deviation of 4.7. The control limits are the same as before, so I already have it pre-marked for you. Draw a control chart plotting the data for the 15-day period. Interpret the control chart. So I'm going to add in my center line where the mean is, so 19.3. I'm going to add that in purple. I'm going to draw in all of those zone boundary lines for the A, B, and C, just nice and dotted. Doesn't have to be perfect. Okay, and then same thing down here. Again, I'm not expecting perfection. And they can be solid or dotted. That does not really matter. Okay, and then if I mark the zones, right, the C's are right next to the mean. And then as I move away, here is B and A, here is B, here is A. All right, so I'm going to plot my data. So day 1, 25 rooms were not clean. 2, 8, 3, 23, 4, 15, 5, 26, 6, 24, 7, 31, 8, 21, 9, 27, 10, 20, 11, 25, 12, 21, 13, 27, 14, 11, and 15, 16. Right about there. All right, so connect the dots. Okay, so here we go. So we want to look through our list here, and we're looking for, is there a warning sign? Do we see a red flag? Is there something potentially out of control? And on what day would it have occurred? So take a moment, maybe pause and look at your sheet, look at your illustration of tests, and see if you can come up with something. Okay, and then unpause, come back to me, and here is where we should have our first red flag right there on day 13. So I'll mark that with an X. That would have been our first out of control signal. So we're seeing an out of control signal. Again, it's just a warning sign on day 13. And we're going to say why. So we're going to say because of test 2. So if I look over here and I look at test 2, what was test 2 telling me? Well, test 2 is telling me that it looks like there's some sort of shift in the mean because we have consecutive data on one side of the center line. And we see that it's 9 observations in a row on one side, on one half of the chart. So if I go over here, right here is my center line, nice and purple. So I can see that right here I have 1, 2, 3, 4, 5, 6, 7, 8, 9. So right here would have been my 9th consecutive data point that's on one side of the center line. So 9th piece of data on one side of the center line. Okay, so test 2, which was the 9 consecutive observations, here we're seeing above the mean. Okay, and I could actually see that it would have also gone out of control on day 14. So if we hadn't already pulled that red flag right here on day 13, it would have been pulled here on 14 as well. So here, that would have been test 4. So test 4 is saying something doesn't seem right because we're bouncing up and down and up and down and up and down, 14 observations in a row, alternating up and down. So if we hadn't seen that red flag, that's out of control signal pulled on day 13, we would have hit it by day 14, but for a different reason. So clearly, this just indicates that there's some sort of issue. There's some reason for why the mean appears to be rising. So corrective measures should be taken, right? We want to try to explain why would that be playing out. So why is it that we have here more rooms that are being left not made up, right? So maybe we need to hire more staff. Maybe we have more trainees that are working right now and they take more time, or we just simply are understaffed. We don't have enough people working. So we can always provide a little reason. So what did I say? I said perhaps we have more trainees. So more trainees are working. And they just, take more time to clean the rooms, or maybe not enough people are working. All right, if those 2 examples were enough, then great. If you want one more, let's do one more. All right, so here again, same setup, but now we're looking at a different 15-day period. So again, I would start by drawing in your center line. So right here where the mean is, that's your center line. So I'm going to mark that in purple. Okay, and then all of my other zones, I'm going to mark those in red. They can be dotted, they can be solid, it doesn't actually matter. Trying to move fast. Okay, and then I need to do the zones also. So here, C and C, right, because I'm close to the mean. I'm within 1 standard deviation of the mean. And then as I move out, B and B, and from here to here, 2 standard deviations from the mean. And then here to here, A, 3 standard deviations away from the mean. Okay, plot your data. So 1, 29, 2, 14, 3, 18, 4, 21, 5, 11, 6, 20, 7, 35, 8, 24, 9, 19, 10, 12, 11, 19, 12, 6, 13, 8, 14, 11, 15, 20. Okay, connect your dots. All right, there we go. Here's our control chart. So pause for a second, look over your chart, and see if you can find an out of control signal. Sometimes there's more than one. Sometimes there's many things that are out of whack in our system. Okay, for me, the first one that I was able to identify was right here. Right, once I'm out of zone A, I know that there's an issue, right? That's very unusual to be beyond 3 standard deviations of the mean. So here we're going to say, well, we are out of control. On day 7, and then we state what test it was. So because of test 1, we have 1 observation beyond zone A. Okay, and then can we think of some reason for why that could have happened? Well, we could see that maybe an employee called in sick that day, so maybe they were just understaffed for that day only. That's a potential reason. So maybe we have a sick employee, or maybe this was, a special holiday where many people booked the hotel and they were just having trouble cleaning the rooms. Okay, so that for me was the first red flag, right? X marks the spot. That's the day it happened. And I can also see that down in here, I'm actually seeing here that we have a significant amount there in this lower region. So if I look back at my chart, I might identify that I see 2 of 3 observations in a row on one half of the chart and in zone A or beyond. So if I'm looking here, that is exactly what I'm seeing. So I'm seeing 2 of 3 in a row are on one half of a chart and in zone A or beyond. Well, here and here, this is zone A. So zone A, here, these 2 are in zone A. So this would have been the first of the 3. So 2 of 3 zone A or beyond. And it's always on that 3rd day. So here's 1, it's on the lower side of the mean. And then here, these are the 2 of the 3 that are in zone A. So I could also see that if I hadn't noticed a red flag over here on day 7, I would have seen another issue over here on day 13. And on day 13, that would have been test 5, 2 of 3 observations in a row on one half of the chart. And in this case, it looks like they're being really efficient, so maybe they're overstaffed. Maybe they have too many people on staff because they're leaving fewer rooms made up, or fewer rooms are not made up by 3:30 down in here. So they're being really efficient, maybe overly efficient. Maybe they are overstaffed in this instance. All right, that's all I got for today. I hope you guys are liking the control charts. Kind of fun, kind of nice real world application. For these, all my expectation is can you graph the data? Can you use your chart? You'll always get your chart on any quiz. Can you find where it would have gone out of control? Can you give me an explanation for why it could have gone out of control on that day? All right, so all I got. Have a wonderful rest of your day.